Hey everyone. Today we're going to crack open the black box of artificial intelligence. We're going to get right into the fundamental blueprints, the core designs that allow an AI system, whether it's in your phone or in a car, to actually think and act in the real world. So think about this for a second. A self-driving car. How does it actually make thousands of little decisions every single second? It's not magic, not by a long shot. It's all based on a specific kind of program. And we're about to break down exactly how it works, piece by piece. All right, let's dive right in. To really get how an AI like that works, you gotta start with the most fundamental concept of all, the agent. You know, for all practical purposes, every AI system we build is designed to be an agent of some kind. Okay, let's make this super simple using our self-driving car. It perceives the world, right? It uses sensors. That's its cameras, its GPS, its radar. Then it acts on that world using its actuators. That's the steering wheel, the gas pedal, the brakes. And that little loop is the heart of it all. Perceive, think, act. So let's try to build our own AI's intelligence, right from the ground up. We're gonna start at level 1, the most basic version you can imagine, the simple reflex agent. A simple reflex agent has, well, basically zero memory. None. It lives completely in the now, and it has no idea what happened even a second ago. All it knows is what its sensors are telling it right this instant. And its logic is just a simple list of if-then rules. For example, if the sensors see brake lights, it brakes. That's the entire thought process. It's a pure reflex. It's just like when you pull your hand away from a hot stove without even thinking about it. Super fast, super effective, but only if the world is simple. And you can probably already see the massive problem here, can't you? What happens if the world isn't simple? What if that car in front of you goes behind a big bus? Our simple agent, with no memory, would just forget it exists. Which, yeah, could lead to a really, really bad day. To fix that, our agent needs an upgrade. It needs a memory.
And that brings us to our first major upgrade. Welcome to Level 2, the model-based agent. This is where we give our AI a bit of a memory, which lets it keep track of all the parts of the world it can't see right now.
So here's the key difference. The reflex agent only acts on what it sees. The model-based agent, though, it keeps a little model, or an internal map of the world, in its head. It uses this memory to keep tabs on things, even when they disappear from view. This internal model basically gives the agent a sense of object permanence. You know how a baby learns that when you play peekaboo, you haven't actually vanished? That's kind of what we're giving our AI here. It understands that the car behind the bus is still there. This best guess about the hidden world is absolutely crucial for getting around in a complex place. So our agent is definitely getting smarter. It can react, and now it can remember. But it's still just reacting, isn't it? It has no long-term plan. It's like a car that's driving perfectly within its lane, but has absolutely no destination. It needs a goal. And this leads us to level 3, the goal-based agent. This is the point where we finally give our AI a sense of purpose. It's not just about dodging stuff anymore. Now it's about actively trying to get somewhere specific. The really big change here is that we're moving from just reacting to actually planning. A goal-based agent knows where it wants to end up. It starts thinking about the future, considering different series of actions, like a sequence of turns, and it uses search and planning to figure out a path to get there. This is pretty much exactly what your GPS or map app does. You type in an address, the AI gets its goal. Get home, and it immediately starts calculating a route. Now it's thinking ahead, not just responding to the car right in front of it. But hang on, this creates a whole new, much trickier problem. Your GPS might find 10 different ways to get you home. One's faster, but has a ton of traffic. Another one's slower, but way more scenic. How does the agent decide which path is actually the best? Just having a goal isn't quite enough. It needs to have preferences. To solve that puzzle, we need another layer of intelligence. So, welcome to Level 4, the utility-based agent. This agent doesn't just find a path to the goal, it finds the best path, based on whatever preferences we program into it. And this is where this idea of utility comes in. Honestly, the easiest way to think about it is as a happiness score.
The utility function lets the agent weigh the pros and cons of different outcomes. It might give a high score to safety, a medium score to speed, and a low score to hitting traffic. The agent's job is just to pick the path that gives it the highest total score.
Let's look at our options here. Route A is super fast, but maybe a bit sketchy, so its utility score is a 70. Route C is gorgeous, but you'll be late for dinner, so it gets an 80. But look at Route B. It's the perfect sweet spot between speed and safety. It gets a utility score of 95. That's our winner. A utility-based agent will always pick the path with the highest utility score.
Okay, so far, all of our agents have been running on a fixed set of rules that we gave them. But the most powerful AI systems, they can do something more. They can improve themselves. And that brings us to our final and most incredible upgrade, the learning agent.
A learning agent has this amazing internal feedback loop. It all starts with the performance element. That's basically the agent we've already built, the one that perceives and acts. After it does something, the critic, which is kind of like a coach, steps in and gives it feedback. Hey, that was a good move, or nope, that was a mistake. That feedback goes to the learning element, which then actually makes changes to the agent's internal rules to do better next time. And to top it all off, there's a problem generator that suggests trying new, maybe even weird actions just to see what happens and gain more experience. It's a complete cycle of self-improvement.
So let's just recap that whole journey up the ladder of intelligence.
We started with a basic agent that could only react. We gave it a memory so it could remember. We gave it a purpose so it could plan. We taught it preferences so it could optimize. And finally, we gave it a feedback loop so it could adapt and learn all on its own. This entire structure lets us build these agents that act rationally, that can achieve their goals in incredibly smart and optimized ways. But it leaves us with one last, much deeper question. If you build a machine that can perfectly simulate rational behavior, does it ever actually understand the world it's in? And that's a question that takes us from the blueprints of AI right to the philosophy of what consciousness itself might